Architecturally exposed structural steel. Design with detail. Part 3. Connections. This presentation is brought to you by the Association of Collegiate Schools of Architecture. My name is Terry Meyer-Boak. I teach architecture at the University of Waterloo, and my passion is steel. Steel is extremely adaptable and structurally very strong. As the desired aesthetic belongs to the designer, the choices come down to the selection of your member type and the connections between the members and larger elements of the project. Do you want your project to look more fluid and continuous? Then you are likely to choose welded connections. Do you want your project to look more technical? Then you are likely to select bolted connections. Most likely, you will end up selectively using a combination of bolts and welds, as was the case in Koolhaas's Seattle Public Library. Although the overall aesthetic viewed from a distance gives the impression of a welded structure, the reality of construction on site necessitated the use of discretely done bolted connections to allow for a better construction pace as well as to minimize the need for scaffolding. This detail stresses the difference between connections done on site and those done in the fabrication shop. It also addresses the simple reality that you can only transport elements of a limited size to the site. The diagrammed baskets for the World Financial Center Entry Pavilion by Pelly Clark Pelly were fabricated about 600 miles from the job site. Their finished size required that they be broken down into discrete elements that could be shipped. Although the finished diagrammed basket tiers were 5 modules tall, the trucks could only take much smaller segments, so they had to be shipped separately and assembled on site. The expectations were that the site welds would be equal to the shop welds, so that once complete, the tubes would appear seamless. Although both diagrammed structures, the Seattle Public Library and the World Financial Center are remarkably different, as Seattle uses wide-flanged sections with a combination of welding and bolting, and the World Financial Center uses an all-welded tubular structure. So when it comes down to detailing your exposed steel, the choice between welding or bolting is extremely important, as it will impact the overall aesthetic of the project. It is important to understand that welds and bolts can for the most part achieve the same transfer of load through a connection. However, if you're looking at welds, the reality is that they turn out better if they are done in the fabricator's shop in controlled conditions than on site where access is often not optimal. The choice is yours, but the outcomes can be quite different. Let's first look at some different bolted connections that can be used. This detail is using bolts and plates to connect the members. It is pretty basic AESS, as it is located in a sports facility in a community center. The location at the top left is a bit of a problem. The bolt heads have not been consistently placed. Consistency should be expected in AESS work. The bolting details on this connection are neatly done. Here they are using tension control bolts. These can be recognized by their round heads. They tend to make the overall bolted aesthetic a bit less technical. Bolted connections are used to splice the large trusses on this concert building in Boston. Here, oversized round plates have been welded to the ends of the tubes. Triangular plates are welded between the spacing of the bolt holes to reinforce the connection. The complex framing for the Canadian War Museum in Ottawa, Canada, uses both welding and bolting to join the square HSS members. Stub elements are shop welded to the primary member. These have plates welded to cap the ends that extend out in 2 directions to accept 3 bolts on each side. An alternate detail inserts a plate into the end of the capped HSS member to create a lap joint. The design intention was to mimic a war-torn landscape, so the details were designed quite intentionally with this tectonic variety. The Rose Center for Space in New York, by Anita Architects, uses bolted connections to attach the tubular elements of a truss to the main vertical cord. Here you can see that the plates that receive them are welded to the vertical element using simple unremediated fillet welds. Regular hex head bolts have been used. The plates that are attached to the ends of the tubes have required some good fabrication. The round plate that was welded to cap the tube would need to be ground to fit precisely. The protruding ends are angled and their corners curved. This was done for aesthetic reasons as well as to accommodate the geometry. Were they not tapered, they would not have fit. If we look at this canopy, we can identify two means of splicing the elements that were shipped separately to site due to transportation constraints. Along the bottom chord of the tubular truss, a bolted connection was used where the plate was cut into the tube to keep the lines of the form cleaner. The curved top chord has used a butt-welded connection that will be sanded and filled to the point of making it disappear from view. The bolted connection is quicker to complete than the welded one. It would be up to you as the designer to imagine if the upper welded connection could have been done the same way without compromising the overall finished piece. The extensive exterior trellis structure on Jean Nouvel's 111th Avenue, adjacent to the High Line in New York, uses a special sort of discrete bolted connection to join the members. Here the connectors are recessed into holes, which adds an interesting detail to the connections. Care needs to be taken on exterior detailing to ensure that water will not accumulate and cause rusting, and that proper corrosion protection methods have been used on the steel. The discrete bolted connections used to connect the elements of the tubular roof on this transit station are fairly elegant and maintain the visual lines of the structure while obviating the need to make welded connections on site. When detailing these, you need to be sure that there is adequate room for a wrench to fit into the pocket to tighten the bolt. These extremely long trusses at the Calgary International Airport had to be shipped in 3 parts. You can see here that they designed a pin-type connection for the top chord as they knew it would be well above view level in the finished space, so somewhat less apparent. On the round bottom chord, which would sit quite out in view, they used what is called a hidden connection. What you see here are 2 curved plates that are affixed over a slender bolted connection that fits inside the tube. This allows for fast erection and minimal work to be done on site. When this detail is cleaned up, it will look the same as a more time-consuming welded connection. Here is a view inside of the same connection before the cover plates are attached. Care is taken to ensure that the bolted plates sit inside of the tubes that are being connected. Welded connections are used where a seamless appearance is strongly desired. This raises the costs of fabrication. The designer needs to be more understanding of the processes of fabrication when thinking of member sizes and shapes. In this angular HSS frame, the intersections of the square members must allow one member to be continuous while aligning the transverse members with precise geometry. The welding must be fully ground, sanded, and filled to make it disappear, giving the illusion that the steel is all continuous. Intersecting round members have different challenges associated with their geometry. The diagonal grid on this concert hall is fully symmetrical, making the cuts to the ends of the intersecting tubes identical and therefore simpler to fabricate. The detail was accomplished by making end cuts on all 4 incoming members, completing the detail with a well-done, unremediated weld. Although the building appears to be round or curved, all of the intersecting members are straight. The tubular structure on this bridge in Seattle uses curved members, so it was important that the hoops be complete in at least one direction. This required a different type of welded connection, and obviously from the form of this structure would not have been well served by bolted connections. Here you can see the way the joining tubes needed to be cut to make this connection. Again, the welds were left alone, as to have asked for these to be ground and filled would have added tremendously to the cost of the project. You can also see some of the weathering issues when designers select white finishes on exterior applications. They are highly prone to staining. In putting together a welded connection, the cut is carefully laid out on the tubular member. The cut tubes are tack welded together and then fully welded for a full seal and full strength. This might take multiple passes by the welder. The finished welds may or may not be remediated by grinding and filling. This can add a lot of cost to the detail. The steel is usually primed before receiving its final coating. This is a view of the finished truss during the erection of this pedestrian bridge. There is much that can be done to create relatively complex structures through the combination of standard steel shapes like HSS tubes and welding. Care has to be taken in creating details that understand how elements are fabricated. The junction of the round HSS sections on the truss for the abilities center used plate steel to solve the geometry issues presented by the connection of the three round sections. This obviated the need for contour blending and created a beautiful detail out of the juncture. This contrasts with the wind bracing trusses on the Beijing airport that have chosen to contour the welds between the tubes. There are certain details that have become almost classic in terms of their application and detailing. This would apply to the end details of the tapered struts that hold up this truss. The desire is always to taper the ends of the tubes as they connect with the pin support at the plate to create a more elegant visual transition. The fabrication of this detail requires that an elliptical shape be cut from either side of the tube. Plates are cut to fit the cutouts and tack welded into place. A plate is welded to the end of the tapered tube, to which a pair of plates with the holes that provide for the pin connections are welded. All of the welds are completed, ground, and filled to give a continuous appearance. The connection at the bottom right is from a different project, but uses the same sort of detail. I've only touched upon some of the basic ideas behind connections in exposed steel design. For more information and lots of case study examples and photos to inspire your work, feel free to connect with me on my AESS Facebook page. And for more detailed information on designing with architecturally exposed structural steel, check out this book on the topic. It is filled with plenty of photos like the ones included in this presentation and more valuable tips on fabrication, erection, design, and detailing.